Thank you. Could I have my slides, please? Peter and Partha, thank you very much for the invitation, and thanks very much to both of the academies and to Monsieur Sanchez for providing us an opportunity to get together and wrestle with some really important problems. I'm going to focus squarely on the ocean in my remarks, and I can sum up what I'm going to say, I think, in about 4 words, which is urgency and cautious hope. And I'm going to be speaking from the perspectives of an academic who has studied marine biodiversity for most of my career, but also from the perspectives of a policymaker, a government policymaker from the 4 years that I spent in Washington, D.C., and an additional 2 years being a diplomat for science as the first U.S. science envoy for the ocean. And those perspectives have given me a richer understanding of some of the issues that we're wrestling with today. I think it goes without saying that we are a terrestrial species. We have terrestrial biases, we have terrestrial affinities, and for eons the ocean has been something else, something out there, either exotic or strange or terrifying. And I think it's only recently that we've really begun to appreciate how much diversity is in the ocean, number one, and number two, how very threatened it is, and number 3, how that actually has very real consequences for our own lives, but in particular for the poorest people around the world. So this is a very urgent challenge that we have to better understand it, to deal with it. Many of the discussions we've had so far are equally appropriate to the ocean as they are to the land. So today I'm going to give you just a very brief glimpse of some of that biodiversity, a sense of the magnitude of the threats, but I want to focus most of my remarks on some of the integrated solutions that are bubbling up from around the world about how people are thinking about changing practices and policies to get us to more sustainable ways of living in harmony, not only with the ocean, but indeed the planet. And that transition, I believe, is far from assured. It's a very huge challenge, but I think there are signs that if we pay attention to them, that we might be able to make this transition, not only because it's our responsibility, but because it's also in our own interests. So, as we think about life on Earth, most of us tend to think about animals and plants, the things that we can see, many of the things we've been talking about. I just want to begin by reminding us that, in fact, life on the planet is much richer than just those things we tend to focus on. Even within the eukarya, the animals and plants are just the 2 top branches among those. So let's just keep this broader world in mind, and we know very little about most of that. In the ocean, we know that it's huge. We know that it's immense. I think for many people it's been just this blank blue out there, and we are discovering that it's actually full of diverse forms of life. If we think about habitats on land, clearly there are a wide range of types of habitats, and we have different biodiversity in different types of those habitats. They're connected to one another, both through the movement of critters as well as energy flows, nutrients. But if we put land in perspective to the ocean, we can do the following. Think about how the land, which is connected to the sea also has this full range of habitats. As many different types of habitats as we have on land, they're just with different characteristics. And I want to make an analogy for you just to make a very simple point. If we think about the habitable space on the planet as a series of apartments in an apartment building, there's a single apartment that is on land, and there are 99 apartments in the ocean. Now, these aren't equivalent to habitats, mind you. This is just to make the point that 99% of the habitable space on Earth is in the ocean. And we tend to forget that. It's not just that 71% of the surface area is the ocean, but 99% of the space that is habitable is in the ocean. Despite harboring only 2% of the known animal species, I would argue that diversity is actually much richer in the ocean. And people tend to focus on number of species as a surrogate for biodiversity. My point is that there are other ways of looking at biodiversity, and different body plans, different ways of making a living, different phyla within the animal kingdom are, I think, a more appropriate way of thinking about biodiversity. If we look at the different phyla of animals on land, 91% of the critters on land are in fact in a single phylum. They're all arthropods, lots and lots of insects. In the ocean, only 21% of the species are arthropods. And you're well familiar with many of those. You eat many of them, crabs, shrimp, etc., lobsters. But there are a wealth of other phyla in the ocean that are, first of all, there are more of them. There are 19 total phyla on land and 35 phyla in the ocean. So there are a lot more different types of ways of making a living in the ocean. And although there is only one phylum that is exclusively terrestrial and only one that is exclusively found in the freshwater, there are 15 phyla that are found nowhere else on Earth except in the ocean. Echinoderms, the sea stars, and their cousins are an iconic example of that, but there are 14 other phyla that are found exclusively in the ocean. So this is just to remind us and broaden our perspectives about what the biodiversity is that we're talking about. It's not just number of species. To make the point in a slightly different way, a single marine habitat, specifically coral reefs, hold a phenomenal amount of biodiversity, more than 50% more phyla than all of the terrestrial and freshwater habitats combined, despite the fact that coral reef, total area in coral reefs is about 460 times smaller than that freshwater and terrestrial habitat. So rejoice with me in the wealth of biodiversity in the ocean. It's just amazing, it's spectacular. And it's all the bizarre creatures that we often don't see. So just the very first point, oceans harbor most of life on Earth and the habitable living space and lots of different kinds of critters, most of which we're not very familiar with. Point number 2, ocean life currently experiences many more diverse threats than does life on land. So you're saying, I don't know if I believe that. Well, let's take a journey through time. Forgive me, paleontologists, this is going to be quite abbreviated. So pre-1900s, okay, Neil, hang on. Okay, pre-1900s, the anthropogenic now, drivers of extinction, were primarily hunting. The major impact that people had was primarily through hunting, I would argue. In the 1900s, in addition to hunting, although that became a lot less important, other things, invasive species, habitat destruction and conversion, and toxins have become more important. In fact, Paul made the point earlier that habitat destruction is the single biggest threat to biodiversity on land right now. So we have, through time, those plus now climate change. So through time, we've added more threats on land. If we compare that to the ocean, in the ocean now, pre-1900s, human impact on the ocean was next to nothing in terms of major drivers of extinction. People fished, they fished for a long time. Impact on the ocean, not very much. 1900s, fishing began to have a major impact on the ocean, and also, simultaneously, invasive species, It's transported by ballast water around the world, habitat destruction, bottom trawling, conversion of habitats close to the coast, and toxins. By the present time, we have all of those plus climate change, and we have more hypoxia, areas of low to no oxygen, partly a consequence of climate change, partly a consequence of other things. We have all this plastic pollution that's out there that's fundamentally different from the toxic and nutrient pollution that we had earlier. And we have ocean acidification, also partly as a consequence of excess CO2, or as a consequence of excess CO2. So I would argue that the drivers of extinction in the ocean are now, all of a sudden, much more diverse and much more serious than they were previously in the ocean. And I think that's just context worth keeping in mind. So it raises the question, are marine and terrestrial species differentially susceptible to extinction? We've long thought of the ocean as being this vast, immense place. Neil drew attention this morning to the importance of broad geographic ranges. Certainly many species in the ocean have very large potential for dispersal. Some range widely, others, the adults don't, but the young can be dispersed. And so it's long been an operating assumption that in fact extinction was less of a problem in the ocean because of these factors. And it is absolutely true that in terms of documented extinctions, we have only 15 in the ocean versus about 514 on land in modern times. And so, again, there has been this assumption that marine species were less vulnerable to extinction. There are other hypotheses that are out there. One is that the low rates of marine extinction simply reflect the fact that we don't have as much information. We don't see all the extinctions that happen. We don't know all of what is going on. We have less knowledge of what's there to begin with. And in fact, a recent analysis by Webb and Mindell went through all the IUCN data on species that both marine and non-marine, so non-marine is terrestrial and freshwater, and looked at extinction rates for both species that were, as a function of how, whether they were assessed or not. And they discovered that the best assessed marine and non-marine groups have equivalent risks of extinction. So 20 to 25% of marine and non-marine taxa are at risk of extinction. So they're suggesting that in fact, part of the difference is just the difference in the knowledge base that we have. So there remain different explanations for differential susceptibility, but I think the major conclusion is that life in the ocean is indeed currently at great risk. So why might marine species be vulnerable? Yes, a lot of them are wide-ranging. Some of them have broad geographic distributions. But in fact, many of those inhabit multiple habitats during their life history. So the young, in this case, boccaccio, a fish, are born in the open ocean. They spend time in seagrass beds as juveniles. They move to boulder fields as young adults, subadults, and then to deep water caves as adults. And so every one of those habitats, if that habitat is in fact seriously compromised, then that species is at risk. And so this is one of the reasons why there is reason for concern. Another is that there are many of these diverse threats. The ocean is warmer, stormier, more acidic, lower in oxygen than it was even 50 years ago. And I spoke of habitat destruction earlier, but I want to make a point of how many different ways we are modifying the habitats in the ocean. It's not just bottom trawling. It is noise, which is a major disturber of some types of marine species, especially those that depend on sound to communicate with one another or to orient. Vessel traffic is a very real problem, and most of the goods in the planet move by ocean. Fishing gear entanglement, especially for what's called ghost fishing, so nets or pots that are lost at sea continue to fish even though the fishermen aren't getting those fish out. Bottom trawling, reef construction like what China is doing in the South China Sea now, and expanded mineral, oil, and gas extraction are all variations on this theme of habitat destruction. One of the most sobering aspects of this is that the areas that are highest in biodiversity tend to coincide with those very areas that are fished most heavily and that are likely to be most impacted by climate change, in particular warmer waters. And so we've got a real problem, especially for the massive number of poor people in developing countries that depend directly on seafood for their primary source of protein. Those areas in the tropics are going to be most heavily impacted. So there are major challenges ahead in terms of consequences both to biodiversity as well as to humans. What do we think our best expectations are with respect to mass extinctions in the ocean going forward? This shows data starting 70 million years ago, so just the last mass extinction event, both for bivalve, for mollusks that are the gray symbols there, and for vertebrates, which are the little fish teal icons. Those are vertebrates. So that's been relatively steady. Focusing on those species for which we have the best information, this particular analysis suggests that we are indeed entering another mass extinction event in even the most optimum, the low estimates, and then the higher estimates on the far right suggest very significant potential extinction in the not too distant future if nothing changes. So this message is one of very grave concern with very real consequences. I think it's fair to say, is this hopeless? Many of these drivers of change are ongoing. They're only accelerating with population growth, increased consumption. Is there any way that this might change? And I think that I would conclude it's not hopeless. And I am cautiously hopeful, primarily because there are lots of really innovative solutions that are science-based, that are community-based, that are bubbling up many places around the world addressing some of these problems. They're not yet at the scale they need to be, and they're not as integrated and holistic as is needed to be. They have to, obviously, be connected with efforts to address population growth, with efforts to address rates of consumption, but I find some of these solutions to give us hope. And so I want to describe a few of them very briefly, just with a series of images to convey problem and solution. The first problem is chronic overfishing, which is really plaguing the oceans every place. Hopefully, or luckily, we are seeing in many instances very significant reforms to fishery management. More currently in developed countries than in developing countries. But there are many lessons that have been learned about that fishery reform. And that has very real consequences not only for biodiversity, but also for food security. I'll say more about that in a minute. But part of the overfishing story is also having to do with the massive amount of illegal fishing that happens. And there, again, are a number of new solutions. There's a lot more political will to address illegal fishing. Interpol now has an international fishery crime unit. We have an international agreement that countries have signed has come into force where they agree to work together and not allow vessels that have been identified as fishing illegally to come into their ports. So there's more political will. There's also new technology where we're using satellites to tell what boats are doing on the water, where they are. And the image on the lower right shows you the lights from boats that are on the water in the middle of the Pacific. And the blue areas are marine protected areas, fully protected marine protected areas where the fishing boats are not going. And you can see that they're not going. And if they go in there, you can see them, and then you can send a vessel to apprehend them. So it is possible to use new technology to help address some of these problems if it's coupled with the political will and the greater awareness of the problem. Another major problem has been loss of habitat, and we are seeing increasing appetite for creating fully protected marine reserves. I'll say more about that in a minute as well. And then I just want to flag the importance of climate change and ocean acidification. And clearly, the Paris Agreement is not getting us as far as we need to go, as fast as we need to go, and we're not quite sure what its fate will be. But there is increased political will, not enough on that front, and it has to be integrated with these others. So let me say a little bit more about a couple of these solutions and problems that I mentioned. Fishing has a lot of collateral damage. Much fishing is not selective. There's a lot of bycatch. It might destroy habitat. It might entrain, in this case, a turtle, but marine mammals are often casualties as well. Fishery reform, if done properly, can address not only the overfishing problem, but also the habitat destruction and the bycatch problem. And the example that I'll give you is one that I dealt with directly when I was at NOAA. And in this case, working closely with fishermen who were leading some of the reforms and new legislation that mandated the end of overfishing and good science and use of science to set quotas has resulted in some very impressive turnaround in a number of the fisheries in U.S. waters. The Pacific groundfish fishery, which is off the coast of Washington, Oregon, and California, about over 90 different species of fish, had been particularly destructive. It was so overfished, in 2000 it was declared a federal fishery disaster. We did a massive overhaul of that fishery. The fishermen chose to do a new type of fishery management instead of the race to fish, which is common for most fisheries. They adopted a rights-based approach to management, and that has completely flipped this fishery from a disaster to a model, with a reduction in accidental catch by 2/3, and now 13 of the species are certified by the Marine Stewardship Council, independent third-party verifier of sustainable fisheries, and 40 of the species in this fishery are rated by the Monterey Bay Aquarium Seafood Watch, another independent certifier, as best choice or good alternative. So the message here is that it is possible to reform fisheries. It takes political will, it takes good science, but it also takes changing the incentives for fishermen. And the traditional common pool fishery management that characterizes too many fisheries provides fishermen with the wrong incentives to fish as hard and fast as they can today, because if I don't catch every fish I can, you will. And the adoption of well-designed and appropriate rights-based systems can be transformative in fisheries. In U.S. federal waters, I will just give you a few pieces of data to bring home this point. In the year 2000, there were 92 stocks of fish that were overfished. By the year 2015, that had been slashed to 29. So that's really impressive ending of overfishing. Not that it's completely ended, but we're really headed in the right direction. More impressively, there were no stocks that had been completely depleted and then rebuilt to the point that they could again be fished. But in the year 2015, we now have had 39 rebuilt stocks. So it is possible in many fisheries, not all, it is possible in many to recover these depleted stocks. And the reason we've been able to do that in the US has been both this tough law with teeth and timetables, but also the adoption of rights-based plans, which are now are the place where many of the good news stories are emerging. So that's a developed country, US-centric focus. There's a very similar story that is happening in a few developing countries around the world. Belize is one of those. There has been very significant overfishing in Belize, but again, involving fishermen, involving communities, changing their incentives to be able to have exclusive access to fish in certain areas has been truly transformative and has resulted in a very significant turnaround in the fishery, but also in the marine protected areas, the fully protected areas that the now fishermen are guarding because they value them, they treasure them, instead of seeing them as a place to poach. And we're now seeing many more rights-based fisheries adopted around the world, with over 40 countries now doing some kind of secure access. Not a panacea, not appropriate for all fisheries, not going to fix all fishing problems, but a very useful new tool in the toolbox that in fact can be transformative. We're also seeing new incentives for business people and governments to reform their fisheries by analyses such as this from Chris Costello, Steve Gaines, and their colleagues in a paper that was published in PNAS in 2016. These data show you a comparison of 1980 and 2012 with the total fisheries, I can't even read that from here, fisheries that are near the target biomass is the blue, and the orange color are the profits. So between 80 and 2012, a significant decrease in the fisheries at target biomass, so there was a lot more overfishing, and profits had not changed much, so people were fishing harder and harder, essentially, for about the same profit. Fast forward to predicted by 2050, under a business as usual scenario, we're going to have many fewer fish and fewer profits. If instead that business as usual would, if we could put into place instantaneously good, smart fishery reform, and those fisheries involved rights-based options, the best calculation suggests that in fact we can have many more fish and more profits. So this type of incentive, which says continued business as usual overfishing is only going to lead to more disaster and is not profitable. There is an alternative. We can rebuild and we can have more profits, but to do that, there needs to be some investment to get from one point to another. And so that transition to more sustainable practices and policies is how to finance that transition is the key. This is a trajectory from the same analysis of Costello et al. This is the percentage of the healthy stocks in the ocean as a function of time. The green is until today. The dark blue is business as usual, and the light blue, the teal, is with these fishery reforms. So we have a major opportunity to transform fisheries, and there is huge triple bottom upside of that transformation. More food, which is huge in this need for greater food security, more profits, and which is obviously of interest to the industry, and more fish, not only to be caught, but in the ocean because they play such a key role in ocean ecosystems. So this triple bottom line upside analysis suggests that it is possible under a changing climate. There are challenges with that, but if we don't do those reforms, the challenges are going to be even greater. The second solution that I want to highlight was fully protected marine reserves. So these are areas that protect habitats and biodiversity. They also can help recover depleted fisheries and recolonize areas, rebuild them. We know from scientific information that in fact, when you fully protect an area from fishing, you usually have major changes. Things get big and abundant and diverse inside. Much of that biodiversity spills out to adjacent areas. And in fact, that scientific information has been useful. It's been necessary but not sufficient in convincing many players to increase the abundance and the size of fully protected marine areas. A decade ago, so this figure shows, starting in 1955, the fraction of the ocean that was in any kind of protected area. And you can see that it hovered at about 0 to 1% for a long time. And just in this last decade, it's really shot up significantly. So in one decade, we went from 0.1% fully protected, strongly protected, to 1.6% of the ocean. So very significant increase just in this last decade. And I would argue that much of that has been driven by leaders in different countries who have become convinced that A, this is a legacy issue, it is an important biodiversity issue, and they have an opportunity to do something. And so there's been sort of an unwritten competition, if you will, among leaders for mine is bigger than yours. When President Obama took office in 2008, 5% of the US exclusive economic zone was in strongly protected status. By the time he left, it was 23%. That is quite impressive. There are many other countries just in the last 2 years that have created very, very large marine reserves. Palau, 83% of its EEZ takes the prize, but Chile, UK, New Zealand, Seychelles, US, all have very significant fractions of their EEZs. Now, you might say, how can those fractions be so high when still the total amount is around 1.9%? The reason is the high seas. These are just areas of the ocean over which countries have jurisdiction, and it ignores the other half of the ocean that's in the high seas, which in fact, with the exception of the Ross Sea Marine Protected Area, doesn't have any protection. So huge opportunities on the high seas as well as in other EEZs to be making more headway here. And I focused on leadership in part because I think what we're seeing is a shift in the social norms and in the personal norms of leaders who have been in position to do something. This is not an economic issue. You can make an economic case for many of these big protected areas from a tourism standpoint. That's not what's driving this. This is a shift in social norms. And one question is how to accelerate this and also how to protect them from other leaders who might not have the same behavioral inclinations. The third example that I want to highlight is the key role of industry here in being part of the solution, not just part of the problem. And I've been recently participating in a dialogue led by the Stockholm Resilience Center with the CEOs of the 8 largest seafood companies in the world, so both fisheries and aquaculture. And obviously the private sector has a key role to play here. These 8 companies in what is called the Geneva Dialogue have agreed to, first of all, they wanted to hear from scientists about what's happening. They were very concerned about a lot of global changes. They didn't know what to believe and what not to believe from what they read. And so they were anxious to hear from scientists. And in addition to that, they have agreed that they want to be leaders in more sustainable seafood production. And they have made a public commitment now that was announced just a couple of months ago to begin to make their practices more sustainable, to work together to address a number of the problems that have plagued both aquaculture and fisheries. And so in addition to governments taking action, which is what I described earlier, this is industry stepping up to the plate, excuse me, maybe, because it remains to be seen how successful this dialogue will be. They need to convert the aspirations to actual concrete actions, and then they need to deliver on those. But I am hopeful simply because they are willing to sit down with scientists and talk about these issues and say, okay, what can we do? And I think, again, this is changing of the social norms and personal norms, which I believe needs to be part of the solution. So some of the common themes across these successes have been changes in both economic and social incentives, which are triggering changes in policies and practices. We mentioned fisheries, changes in policy enabling aligning short-term and long-term economic incentives of the fishermen themselves, marine reserves, changes in social norms and personal norms, industry leaders, appeals to leaders to lead change, I think, again, are promising. All of this is obviously directly relevant to the achievement of the Sustainable Development Goals. Goal 14 focuses on the ocean. Even though there was a lot of talk in the development of the SDGs about the need to integrate across them, we still have too much siloing in these, and to really achieve these goals, we need that kind of integration. And much of what I've been focusing on, I think, illustrates some of those connections across the different SDGs. So I think there are a number of solutions that are out there. They're bubbling up. They're becoming very common in some places. They're not anywhere near the scale that we need. Many of them have to be made relevant to a place. And it's not unlike what Gretchen and Steve are talking about with the work they've been doing in China. I've been working with Chinese on some of these issues as well. I think many of the solutions exist, but they're not yet at the scale. And so one question is, what do we need to replicate them, to scale them up? Will these solutions be enough? Not if they, not in and of themselves. The increasing rates and scales and types of changes that I mentioned before are unprecedented. However, if we don't implement these solutions, then a sustainable future is absolutely impossible. We need these kinds of solutions to enhance the resilience of the coupled human natural systems to these threats. And so I would argue that these solutions are necessary but not sufficient. So in short, ocean stewardship is actually in our own self-interest as well as our moral responsibility. Marine ecosystems provide a wealth of ecosystem services. We've talked a little bit about the food, but it's also half of the oxygen that we breathe, medicines, fuels, climate regulation, disease and pest regulation, coastal protection, not to mention cultural and spiritual values and nutrient cycling. Those are all critical ecosystem services that are at risk as we deplete and disrupt ocean ecosystems. The food security issues loom large. They affect directly the poorest people on the planet, and that is one of the most urgent issues, I believe. Fortunately, we have leaders who are talking about the moral issues here. The ecumenical patriarch Bartholomew of the Orthodox Church declared in 1997 that causing species to go extinct, changing the climate, or degrading the earth are sins. As you are all familiar, Pope Francis has been immensely inspirational and effective in drawing attention to the moral issues that confront us with respect to responsibility for stewardship of the planet and for the poorest of the poor. And I think that That inspiration and that hope, coupled with some very practical solutions informed by the science and by understanding of the history that we have, presents some new opportunities for stewardship of habitats and biodiversity. And I would leave you with the conclusions that don't forget the ocean, they're important. Lots of biodiversity there. Extinctions are very much a threat, and solutions are emerging. They need to be used at scale. And it's both our responsibility and our interest to make use of, to adopt this new knowledge, these new attitudes, practices, and policies. So, thank you very much.